next speaker, Alexander Kneppers. So during the last 25 years, Alexander has held different positions in RNA profiling laboratories, and now he's head of laboratory of DNA profiling within the Department of Human Biological Traces of Netherlands Forensic Institute in The Hague. As we can imagine, Alexander has extensive expertise in laboratory quality management, lab automation programs, and LIMS systems. So please.
This one? This one's better. Okay, thank you for the introduction and for the invitation to talk about forensics and forensics, DNA forensics. Although we are in a session of biobanking, what I will do is talk to you about automated sample handling, including the storage of forensic samples. But actually, we don't really do biobanking, as you might imagine. First, I will talk a bit about the Netherlands Forensic Institute and the work that we do, and then continue with all the automation that we have been doing the last few years, and especially for trace samples. So, NFI operates mostly national, but also international for different customers. On a national level, we do, of course, a lot of work for the police, the public prosecution, defense counsels, and trial judges. And that's also internationally, because, as you may know, in The Hague, we have a lot of trial juries present there. So we do crime scene investigations. We do investigations, of course, within NFI. Do a lot of work for suspects, and in the end, when we have reported our results, also go to the trial to explain those results to judges. So we have three key roles, what we do within NFI. So we do forensic examinations, of course, in crime cases. But next to that, we also do a lot of research and development. And we are also a center of knowledge and expertise. So we give a lot of courses to police, to judges, to advocates, and to different parties, also to other laboratories, for instance, with respect to automation. Just to give you some idea what we are doing, in 2013 we had more than 60,000 cases that we did, with a total staff of about 600 people, with over 40 different forensic disciplines, including the DNA work that we do. And of course, we also have a quality management system. By Dutch law, we are obliged to have an accreditation according to the ISO 17025. And that has been installed since halfway in the 1990s. And of course, we do a lot of internal and external audits. And we have our own NFI expert development program. So the department works not only on DNA, but also on RNA, because RNA cell typing also provides us with a lot of information with respect to the trace samples. So this is an evolving field as well. And next to that, we also do bloodstain pattern analysis. Well, the department is about 100 people, so a large part of the NFI does the DNA work. And then within the casework, we do, of course, crime scene samples. That contains of severe crime scene, but also what we call the high volume crime samples. So then you must think of burglaries, car thefts, and all the traces that come from that. Next to that, we also do a lot of database reference sample typing. So all the convicts in the Netherlands who have to give their sample are typed and put in the Dutch DNA database. Last years, we also do a lot of work with low template DNA. So getting DNA from traces where you know and you expect a very low amount of DNA. Last year, we did a very large, well, not to call it a project, but of course you know all about the MH17 disaster. So we did a lot of DNA typing in that disaster as well. Next to that, we do kinship analysis and familial searches as well. And for the research and development, we of course do a lot of testing and validation, also in automation. We look at ethnicity and visible traits. We do organ typing, for instance, on the RNA level. And the last few years, we also do a lot on rapid DNA services, and that's more the mobile DNA services. So there are a lot of equipment coming on the market that can do DNA typing in just an hour, over an hour. So we are involved in that as well. And of course, in next generation sequencing, so be able to obtain even more information from the trace sample by doing NGS sequencing. So what do we do for DNA analysis? Well, of course, we compare the trace samples and the DNA profile that we get from that to reference samples and try to find a match or exclude a match with different traces. But next to that, we also want to obtain more out of the trace sample. For instance, look at ethnicity or, for instance, hair color or eye color. This is also now allowed in the Netherlands by Dutch law. So, when we go to a crime scene or when we get material to NFI, we first try to identify if there is human material present. But next to that, of course, look to who is the donor. And the last few years also do a lot of work to see what is the relationship to the biological material and the act or the incident that took place. So we do examine the trace evidence, we do the DNA typing, next to that we do the reference sample typing, we do the matching, and if we do have a match within the DNA database, we do the report, or if we don't have a match, we also report it, of course. And with that, of course, the chain of evidence is in the complete procedure maintained. For those of you who are a fan of CSI, just two pictures showing what is on that show. On the left side, you see, well, the crime scene, and you see the victim laying there. And you see a few people walking around, taking samples and doing their investigations. And then when we go to the other picture, you see the lab. There's a big hunk doing the pipetting. And actually, this is not how it works. But probably you knew that already. Because this is the reality. It's far less sexy. People have to wear a lot of protection. Hairnet, mask, gloves, shoe covers. We do have separate labs to prevent samples from getting mixed up. For instance, the suspect and also the victim. And we do very frequent cleaning of all the laboratories to prevent contamination. And that is something we do because we can do a lot of work with very low amounts of DNA. When we do see stains from blood, semen, buccal swabs, it's quite easy to get a DNA profile. But when we go to the lower end, and then we talk about touch traces, so I touch the surface, I leave my cell material there, someone comes, takes a swab, and can make a DNA profile. So it's all about DNA quantity. And of course, inhibition effects in PCR. Of course, you see a lot of multiple donors within stains and degradation of DNA. So the message is, the lower the amount of DNA, the more knowledge we need and the more equipment we also need. And to give you an idea how fast it all goes in DNA, we had about 1,000 requests in 2000, but nowadays we do more than 30,000 cases a year. Of course, having a lot more personnel there, but also the amount of DNA that we now need is far less. So where we needed a lot of cells a few years ago, now we can determine a DNA profile only based on one single cell. And we also get more information, and we type more loci to get to the profile. So that brings me to the lab automation. We do get more and more samples. So that's the reason to start automation. But also because of the sensitivity of the DNA test and the ability to always perform the work in the same manner. automation can help there as well. There's a very high pressure to deliver in time and also to deliver faster and faster. So that could also be a reason for automation. And of course, we want to maintain and also improve the quality of the work we do. And also there, lab automation could help a lot. So this is just a schematic presentation of the workflow that we have within the department. So we have the client, he brings in the case, we have a front desk that registers the case into the LIMS system. And then we have the planning, sometimes in combination with the reporting officer that says something should be done or not be done. We do the trace recovery. We have a full unit doing only searching for stains on all the evidences that we get in. And then it all comes to the DNA lab. Sometimes when it gets difficult, we go to the R&D and then go into the process once we get the results into reporting by the reporting officer and reporting back to the client. The automation that we did covers the trace recovery and also the DNA lab. So we set up a program called NFIPOD, where we stated that we want to do automation on almost all DNA traces, forensic trace samples, and by that eliminating the possibility of sample misplacements, and also, of course, reduce the risk of contamination to a bare minimum. So have less people be involved with the trace sample by doing automation. And of course, where we still see that some processes cannot be automated, try to improve that as well. So we started already in 2010 doing a benchmark because, of course, we thought, well, we're probably not the only company thinking of automation. So we went to other forensic laboratories, but also went to pharmaceutical companies. We looked at clinical laboratories, what they did on automation, and talked to a lot of providers also present here today. And went to conferences like this one. And the result is, of course, the market has a lot to offer. And of course, it's possible also in forensics to start using automation. So the NFIPOD program contained of several different projects within that program. So we did the licensing of trace samples and the extraction of DNA, so the complete process. Quantification and PCR setup, what we do a lot. Post-PCR setup. Reformatting, I will come back to that later. And of course, the storage of all the DNA traces that we obtained. And that all integrated into a homemade LIMS system. And that allows us for, of course, the efficient sample collection. But also what's very important, full track and trace of the sample handling, and of course, a complete audit trail for the sample storage. So we always know what happened to the sample in terms of storage and temperature. It also allowed us to do automation on uses of business rules. We have a lot of samples within the lab, and we know that some of the samples cannot be combined on the same working list. So we should include that also in our LIMS system. And what we call a cutoff system, based on the DNA concentration, where we know if we have very low amounts of DNA, and we know we don't get a DNA profile, then we also stop after the quantification. And of course, less manual handling. And the basis for this automation are these two tubes that you can actually also find at the booth. The first one is the autolyzed tube from Hamilton, and the second one is the Fluidics 0.75 external thread tube Fluidics, and it's the stand of Sopagem. And these we use for, well, of course, the storage, the automated delivery of these samples to our laboratory to perform DNA extraction, quantification, and PCR. And by doing so, we don't have any manual labeling steps anymore. And what we also eliminate is the visual control that we had in a lot of steps within the lab, that two people had to check for the order of samples, something which probably you also recognize. So this is a schematic overview of the process that we have. So on the left part, we have the extraction, where we have the automation part, but also still, for some reason, for some applications, the manual method. And then the PCR setup, first doing the quantification, and afterwards doing the PCR setup. And then in the post-PCR setup, to get the samples for the capillary electrophoresis and the analysis in the end. And what we did is we placed the automated storage either at 4 degrees or at -80 in the center of our procedure. And that is, I think, quite unique. I will talk about a few of these projects, and to start with the automated storage. The goal there was to store all the DNA extracts, and of course don't have any risk anymore of losing or misplacing samples, and have a good sample and data integrity. And you must know that the NFI is obliged by Dutch law to store DNA samples, sometimes for up to 80 years. So we had to think of a capacity that would allow us to store these samples for a very long time. And we decided to have a project to have a capacity of over 1.5 million tubes, and that's the capacity for about 10 years' time. And then, as said, using the 0.75 or 0.5 ml tubes. We, in the end, after tendering, had a fully automated storage solution based on Hamilton equipment, having a BIOS, a SAM, and a rack runner cluster. And within that automated storage, we have 4 degrees, the SAM, and also -80. And why -80? Because in our opinion, for DNA storage, -80 is at this point still the golden standard, and allows us to really long time store these kind of samples. So this is a schematic overview of the storage that we have. On the left side, you see the BIOS, where we store all the DNA extracts at -80, and for intermediate time, also the DNA traces before they are extracted into DNA. Next to that, we have an intermediate storage on the SAM, and that's at +4 degrees, and we use that system to store the samples while they are still in processes. So after the extraction method, the samples first go to the SAM, and from that we collect the samples again to do the quantification and the PCR. Then they are returned back to the SAM, and after 1 month, when the case is closed, they are automatically transferred to the BIOS system. Of course, we can put in and also get out samples from the BIOS directly, and also from the SAM itself. And this is all integrated into the LIMS system. And to show you the BIOS system that we have, this is just a picture when it was just built at Hamilton itself. And it's a quite enormous instrument now at NFI. Then to talk about DNA extraction. For that we, in the end, chose a system from Hamilton after tendering. Here you see a picture of the Microlab Star. And what we wanted there is to also reduce the risk of misplacing and contamination, but also be able to automate almost all of the manual extractions that we did. And that was done for the lysis part, and also for, in the end, the extraction of the DNA itself using manual magnetic beads. As said, this was also tendered for, and Hamilton won with the Microlab Star and the autolyzed tubes. And for the chemistry, we had QIAGEN. And we did a developmental validation for that, for both using the consumables, the hardware, and got an optimized procedure for it. And at this point, we have 3 of those systems. Actually, the 4th one is installed in a few weeks. and that allows us to process over 96% of all the trace samples that we have. We do still have some manual procedures, but that's because these are quite difficult extractions methods to automate. And it's here mentioned the differential lysis. So we do get very high quality DNA with low amounts of artifacts present. Then for the setup quantification, PCR, and capillary electrophoresis, there also we wanted to really reduce all the manual steps. We have there 2 identical systems for PCR setup, which are TCAN systems, and also 2 for post-PCR. And there we also had some challenges in being able to, create the possibility to add and remove samples in working lists. We did extensive validation on different kits. Then another project was what we call the reformatting. And there we also did automation, but then automation of reformatting the DNA extract that is in what we call an old tube, which is not barcoded, doesn't have a 2D code, and put them in a 2D coded tube in an automated way. And why did we have this project? That's because also by Dutch law, the NFI is obliged to also store all the DNA extracts that we get from other laboratories that do the casework in the Netherlands. So they should send us their samples, and we should do the reformatting and storage of those samples. And the challenges there is that we have a lot of old samples in all kinds of different tubes, which we still have to, of course, relabel because we want to barcode them before we do the reformatting. But once barcoded and put in a TCAN system, in a Hamilton system, we do the automated reformatting in the 2D coded tubes of fluidics. Some other challenges there is that we work with quite low volumes, so sometimes also below 15 microliters of DNA extract, and that's also quite challenging in automation. So we finished doing all the validation of the different projects in 2014 in April, and then started another validation, or call it end-to-end testing, where we combined all the different aspects of the automation and looked if they all fitted together to get in the end a good result. Because, you can think of something and end up with something like this bike which will not bring you to the end. And of course we want this one. And therefore we use the end-to-end testing to really know for sure before we started implementing it that we had a good process. This is just to show you that after we implemented NFIPOD, we could in it see that this is based on the high volume crime samples, that we obtain much more DNA in the samples that we extract, and even have a slightly better success rate for these samples. So we do obtain more DNA, and we also get more DNA profiles for them, which is, I think, a very good result. So the overall conclusions are that we were able to drastically reduce all the high-risk errors that we saw before we had the automation, increasing, of course, the appropriate value in forensic casework. We were able to really have much lower amounts of sample misplacements. Actually, we haven't found them since we had this automation. Have now a complete sample tracking and audit trail on the storage. And have, what I said, a better extraction method. And by having this automation, we were also able to save money, and that's the cost part. By introducing also the automated cutoff, we were able to save a lot of money, and also on the personnel involved within the laboratory, and can do the work, the same amount of work with 2 people who left the laboratory. Lessons learned, in our opinion. I started my talk saying, we did benchmarking, and I think that's quite important. So really have a good look in the market, what's there, and it's much better to do it that way than to just browse the internet to see what's there. This project was quite a long project. It was 4 years, and you really should need enough resources. And we have had 3 persons really doing the automation, and also 1 person doing the LIMS part, which is also very important, and has some challenges there as well. And of course, make a good business plan or business case for your management to really convince them that automation is also necessary. And some other lessons. Well, we found that the end-to-end testing was very important. But we also found out that the training of personnel on these complex systems, it really takes a long time. You can do training, of course, the companies will give you training. But for people to really get confident in using the systems, it really takes time, and you should give them also that time. We have multiple users, and we still want a flexible lab, so we also should have a lot of people trained on all the systems. And you also should need key users for error solving, because it's really not walkways automation. I think in the beginning we still had the idea that we also could do overnight runs, just leaving the equipment to go, but really that is not the case. And of course, and it's mentioned before, you need backup. So we have more systems available so that when one system is not functioning, you really have another one present. But even then, still have also some manual procedures present in case of real emergencies. We also invested a lot of time in an error script, and that's on the Hamilton, to also allow that once the robot gives a hardware failure or whatever within the procedure, that you can still move on with your samples, not doing it manually, but just move it on to another system and continue from the point onwards. And we call that the error script. After implementation, it's also very necessary to still have enough resources, because you will always have robots that need adjustments or have adjustments to your LIMS system. And of course, have very good maintenance contracts, because that's, in our opinion, also very important. So that was what I wanted to tell you. Thank you.
Thank you, Alexander. Any question for Alexander? Yes.
Thank you very much. How many replicates do you perform before delivering the result, the final result of your analysis?
That all depends on what we're doing. If we're talking about low template DNA, then we're doing several replicates, 3 to 4 times. If we're talking about typing, for instance, the reference samples, we only do that once. And in some cases, also for the high volume crime, we also do 1 typing.
And the second part of the question is, how do you manage the mismatch between the replicates if you find mismatches?
I'm not sure.
If you have 1 positive and then you confirm the result and you find the result negative. How do you manage that?
Yeah, it's not. That is something we hope not to find, because we then really made an error in the lab. We do the replicates because when we're talking about low template DNA, you really have very low amounts of DNA. When you do the DNA profiling, you will get sometimes different results, but that's based because of the low quantity of DNA. So that's why you should do the replicates, and not because it's a matter of is it positive or is it negative. So that's the difference. Yeah.
Thank you. If I understand well, you have your homemade limbs. So you benchmark for the hardware to get the best one directly, and you make your homemade. What do you call homemade, and why did you choose that solution?
Well, it was not really a matter of choosing that solution. The homemade limbs was already there. I must say, but that's far before my time, there had been some projects going on within NFI to have a commercial limbs, but unfortunately they failed. So that's why we had been working with the homemade limbs, and well, we didn't have a choice. We had to implement it in that limb system. But what I can say is that now the management feeling about having your own software developed has changed. So actually we are going to have another project to have a commercial limbs, to to take over all the well, homemade LIMS functionalities. Yeah.
Other questions?
Yes, I have a question about the training. You said that it is a quite complex platform. So did you try to have several levels of training, for example, a basic training for the user and some expert training to minimize the risk of the utilization of your platform?
Yeah, so we organize the lab in this respect that we have what we call key users. And these are lab technicians that are performing on a bit higher level, to say it like that, and they had a more extensive training on all the equipment and are able to really go into the software, but also to resolve more errors than the other lab technicians. So when an error comes up and the lab technician doesn't know how to resolve it, they first go to the key users, and if they cannot solve the problem, they get into contact with the company to get someone over or to get help from a distance.
You mentioned that you were doing a lot of research around like next-gen sequencing, for example. I mean, how difficult is it for somebody within the forensics world to like adopt new technologies, or the changes in next-gen sequencing, for example, are so rapid? How do you move with the times?
I think the forensic DNA community is a quite conservative community. So I think we all waited a very long time before we actually move towards next-gen sequencing. What you see now is that also companies waited quite some time before coming up with kits for the forensic markets. But now there are kits on the forensic market for NGS applications. So I think this is really the time to start working with that. And for NFI, we have a lot of contacts with universities. For instance, we have a very good contact with the Leiden University Medical Center, where there's a very large facility that does a lot of testing on next-gen sequencing platforms. And we have close collaborations with them, and really feel that now is the moment to start working with that. But then we also have the problem of legislation, because with this new technology, we are able to get much more information from a sample than actually what is allowed at this point with legislation. So we can start developing the techniques, but before we are able to implement them in the casework, we need legislation to change.
Thank you.